Okay, see Lindelof videos. Graphing exponential growth. An exponential function f of x, I'm going to read this to you. Hopefully you're going to stop the video for a second and take this as a note. F of x is equal to a times bx plus k, where b is a positive number, not equal to 1. And if b is greater than 1, we have exponential growth. Two things here, two really common mistakes before we get into this. One mistake is this one, that people think that they can multiply a times b. You cannot multiply a times b. So we're going to look at this function in a second. It's going to be like 2 times 5 to the x. This is not the same as 10 to the x power. Not the same. And the reason it's not the same is, remember PEMDAS, right? PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Right? This is the order of operations. So we're not allowed to multiply these things first. It's a very, very common error, so let's try to avoid it. The other thing I wanted to tell you is that when you have exponential growth, it's going to take on one of these two shapes. It's either going to start, they're always going to start on the left, but it's going to start on the left, and it's going to go like this, and it's going to get really sharp this way, or possibly, if we get a reflection, which we're going to look at today, looks this way, where exponential decay takes on a different shape, and its shape is also always the same. All right, so here we go. Let's try these two functions. Let's do this one. You're going to look really similar. So here's this. We see that the b value is 5, and 5 is greater than 1, right? Therefore, our graph's going to take on this shape, right? So that's an important thing to start with, because a lot of times when your professor asks you to graph this thing, they're not going to pay attention to all the details, but one detail you cannot get wrong is this general shape. So because b is greater than 1, it's going to take on this shape here. And well, that's true, and also the fact that this a value is positive. If a was negative, something different would happen, but we'll look at that in a second. So already we know that this is going to be our general shape. Next thing we're going to do is just take some points that we know. So I'm going to take f of 0, right? So if x was 0, right, so here we are here. Here's the Cartesian line. So if x is 0, we're somewhere on this vertical line right here, aren't we? So I'm going to fill this in. I'm going to say 2 times 5 to the 0 power, x, right? And here we say x is 0. Remember, any number to the 0 power, with the exception of 1, is equal to 1. So this really says 2 times 1, and of course 2 times 1 is 2. So x was 0, y is 2, so we have the point, let's say this is 2 if you don't mind, and we're going to call this the point 0, 2. I'm going to take one more point just to kind of make this work for me. I'm going to take maybe, let's take f of a negative number. So take f of negative 1. So we have 5. Oh, that's not true. That's not, sorry, that's not true at all. We don't have 5 at all. We have 2, right? So we have 2 times 5 to the negative 1. Please remember that negative exponents make fractions. Negative exponents don't make negative numbers. So what we really have here is 2 times 1/5, right? 1/5, because 5 to the negative 1 is 1/5. So we get f of negative 1, comma, whoops, sorry about that. Yeah, f of negative 1 gives us the point, whoops, I'm not going to make this up. I'm just going to show you this because I don't want to waste your time, is the point negative 1, 2/5, isn't it? 2/5. 2/5. So negative 1, 2/5 maybe is here, yeah? So negative 1, 2/5. Remember, I said this is the shape of the curve, so I'm just going to take that curve, right? This is called asymptotic. As we move this way, this thing gets closer and closer to this line right here, right? And then I'm going to go up through here. Now remember, once we get through here, it's going to go up like this. It has this general J shape. You've identified 2 points. Your professor realizes, or your teacher realizes, that this graph cannot be perfect. Right? It can't have the perfect shape. It's not a line where it can really pass through every point that on a Cartesian plane. So this is actually a very good representation of that graph. So remember, this was the graph of this, because the next graph we're going to do is really similar, but it has a distinct difference, and I want to show you what that is. So here we're asked to graph g of x is equal to negative 2 times 5x. Remember the last graph, the last function was almost exactly like this, except for the negative sign. So when you see this negative sign, b is still positive, right? So that makes us think that we have this, right? But because of this negative sign, it's actually a reflection over the y-axis. So it looks just like this, as if we had taken this, as if this was a handlebar, So we've taken it here and here and just bent it, rolled it back over on itself, right, across the y-axis. So going to do the same thing we did before. We're going to take some points. We're always going to take f of 0, almost always going to take f of 0. That gives us negative 2 times 5 to the 0, right? And 5 to the 0 again is 1. So we have negative 2 times 1 is negative 2. So we have the point 0, negative 2. I'm going to go ahead and put my Cartesian plane over here, and I have 0, negative 2, right? So I have 0, negative 2, and so that's 0. Let's call this 0, negative 2. 0, negative 2, right? And then I'm going to take some negative, and I'll say f of negative 1, right? I'm going to take negative 2 times 5 to the negative 1. Please, 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 please remember, negative exponents make fractions. They don't make negative numbers. So this negative 2 is a negative number. This 5 to the negative 1 is actually equal to positive 1/5. And if we have negative 2 times 1/5, we get the point negative 1, negative 2/5. Hopefully you can see some similarities to the other graph. So 0, negative 2/5. I'm sorry, negative 1, negative 2/5. So maybe it's here, yeah? Going to connect the dots. Remember, this line here, as you move to the left, this becomes asymptotic to the y to y equals 0. So I'm just going to finish this off and goes down like this. And here's our function. And of course, we did have 2 points, and we had the correct general shape. Hey, thanks for watching. I hope this is helpful. Please remember that there are just certain things you have to remember about graphing these functions. And if you remember those couple of things, you're going to be really successful in getting it done. So if you haven't already subscribed, please subscribe. And thanks again for watching.